Hey guys, so it's Let's Make, and today I'll be making an air quality sensor for my 3D printers. So reason behind doing this is I've always got my printers on. I don't want to be breathing in any bad toxins or anything coming off them, hence making an air quality sensor which will tell me when to open a window or when I should have more vent or fan go in. So yeah, that's what we're going to be making today. I hope you guys enjoy. Okay, so this is the first design we've got, which will just be a switch, the diffuser and then the case. And this is the circuit. It will have two batteries, TP5400 charger / booster, so this gets up to 5 volts from the 18650s. On off switch after the booster, since the booster only takes 10 microamps of quiescent amps current. Then we need to make sure this is always connected for charging purposes. We've got the LED ring, which is the WS2812B addressable LEDs. We need a 330 ohm resistor so we don't burn out these since they're diodes. We've got the Arduino Nano, which will be the processor for this, and then the CJ-MCU 811, which is a CO2 air quality sensor. Okay, so I made a simple breadboard version of it. We've got the Nano here, the LED ring, the 330 ohm resistor, and the CJ-MCU 811. So I'm going to power it using the last prototype board thing I made in the last video. And this should turn on. There we go. I'm going to put a diffuser on just to block the colour. This changes colour based on what readings we're getting from here. I'm using around about, it depends on the VOC levels, which changes the colours. So anything above 100 is red, and above 44 is orange, and then under that is green. So at the moment there's good air quality in this room. The next stage will be turning this into put it onto a proper PCB and then fitting it inside the case. So what I have here is the circuit finished, put on the PCB board, put the batteries on the back, the charger ports here. I've added a switch, so this now turns on via this. Moving on from this, I created this shell. The first shell is this one, although basically what I was aiming for was the circuit and the whole board to go between these 2 points here, which it does. However, there's this wasted space on either side which isn't needed, so this one is a fail. It's also a bit weak, so if it was being squished, it wouldn't work, especially when you've got the face on. So I need to add something to prevent this from being squished down. This is where version 2 comes in, so it's a bit smaller in comparison. It's also got some slits in, which the face will go onto. That way it will create an extra support for when it's getting squished. Being smaller, it's also just a bit stronger. It's not got much flexibility in it. Yep, so that's this bit. So we've got the printed finished now. We've got the switch going on. You'll see the diffuser lights up. There we go. We've got a grill here, so that the air sensor can get some of the air coming in. It's also clipped so that it can just go on quite easily, with little nudges here to go into the slots. The clips go into the sides. It's also rechargeable, so you can charge it now. I've also glued down the main board as well as the charging board. You can still take the Arduino out if needed, but I'm not going to. As well as the sensor. This didn't take too long to print. Now for the readings, so why it changes colour, there's 3 stages. You've got green, which is obviously good air. The second is like an orange ambery colour, and the third would be a red, which obviously you need to open a window or get some sort of airflow going. So the figures I'm using are anything below 44 parts per billion is green, anything above that is amber, and if it gets to 100 or above, it then goes to red. The reason I chose this is I did a bit of research under what different countries and like the World Health Organization say they should use, and these are sort to be the figures that most of them even out to for like 8-hour prints or 8-hour exposure. So yeah, that's that bit done. Okay, so thanks for this video. I hope you guys enjoyed it. This is the end product. Obviously it works really well. I've tested it for a while. It seems to be working perfectly fine. I just want to do a shout out to Kira Fagan, who redesigned my logo, so thank you to her. Like and subscribe, of course, and I've got a few projects on the work now, so they'll be coming out in the next few weeks. So definitely hit that notification button, and yeah, I'll see you guys soon.